Hi guys, this is a Test Electronics video demonstration on how to build your own test fixture. And what we wanted to do here is come up with a way for all engineers who can design circuit boards to be able to build a test fixture without any equipment. No machining, no drilling, nothing. We wanted to harness your abilities to design circuit boards. So what we came up with was our prober-based test fixture, which is adjustable for the press plate, so you can adjust these press downs wherever you need, and to make a bed of nails plate with nothing in it but a hole, like this. That's all there is. That hole matches one of these project boxes. If you look closely, you'll see that hole matches this. And these come in various sizes. This is a 14-inch prober, which is our middle size. They go from 8 inches to 22 inches wide, depending on what you need for your circuit board. But basically the idea was to design something where you don't have to bother drilling press plates or bed of nails plates anymore and wiring it up. None of that. So what we came up with was building a whole complete test fixture on a circuit board. Since you designed your circuit board, you can design this. All you do is you copy your test pads onto this board, route the test pads out to what you need to display your test results, which is LEDs in this case, and a switch to start the functional test. And what we have here are some chips which amplify the signals, signal conditioning chips for the signals on these test pins. And the nice thing about this is these signal conditioning chips are right on the test pins, as close as you can get. If you had a wired fixture, you could never do that. But now the thing about this is this is the whole fixture right here. You could put this in this project box like this and have yourself a little R&D fixture. Clamp these Destaco clamps down and hold this down and run your test right here. Plug a power supply in here and run the test just like this. And this is good for R&D or pre-production and low volume testing. Then you want to get into high volume testing. We've got a test fixture for you. So you just put it in this. There's 8 screws, of course, that you need to put down around this edge, but for demonstration purposes, you don't need to see me turning screws. You just close this and lock it down, and in here you start your test just like that, and you can watch your LEDs and verify that it passes. Now that's the manual way to do it. I'll get into more automated ways later. I just wanted to show you the easiest way first so you get the basic concept down. Now, this is the simplest kind, a single circuit board. This is a double circuit board. Now the difference in the fixture, the only difference is this is raised ½ inch right here. We just put a ½ inch spacer under there. That's all it is. And the reason for this ½ inch is because we use 2 circuit boards. This circuit board is a little bit thicker than that one. That was a 0.09, this is a 0.125. But the main thing is we've got this top circuit board up here. And what this does is it gives the equivalent of a 3/4 inch piece of FR4 or G10 material thickness to guide these test pins. So there's a much higher pointing accuracy using this method. But it's also a more costly method because you have to have 2 circuit boards. But here again is a fixture all in one. You can put this in the project box like this, put your 8 screws in and plug a power supply in and run it through its tests manually. Flip the switches, verify that the right LEDs come on. Here's some little instructions on what should do what. But that's basically how you design a circuit board based test fixture. And what we have made for you is a kit that's a frame for your circuit board based test fixture. So all we're basically providing for you is a mechanical frame. Now a few nice features this mechanical frame can provide, other than just an easy way to do production testing, is you got a switch here which can apply power when the lid is closed. You've got front and rear panels and a big area. Now there's a cover that goes on this, so This is not always open like it's like here, but you got a big area inside here where you can put a power supply on the back panel right in here, and you could put a voltmeter, a current meter, and an on-off switch and some power indicators here. For this basic thing, that would be a basic way to modify one of these fixture frames. I keep wanting to call these test fixture kits, but they are now test fixture frames. Another way to modify these would be to put our inserts in. We have a microcontroller insert that you can put in here, and you could run a ribbon cable up to this to control this whole test automatically. And we even have Bluetooth controlled touch screens using the Android operating tablet PC that can mount in there. And I'll show you that right here. Here's a unit with a microcontroller built into it. This just pulls out. And here's one with the Android tablet PC built into it. It's got a touch screen. The inside looks like this. Here is the microcontroller. And here is the Android, and the Bluetooth is there. Oh, also here we got a power supply, if you can see that there. And this is a very small power supply. You can get bigger ones, depending on what you need. Our very smallest style fixture back here has a little tiny power supply, a 12-volt switching power supply right here in its little back panel. And the microcontroller there. So that's how these fixture kits work, and that's how you can build your own test fixture with no machining required whatsoever. All you need is the experience you already have in building a circuit board, and to know how to copy your test board pads onto this, how to add a little bit more, like some LEDs and some signal conditioning circuitry, which I'm sure if you design this, you can design this without any problem. And we'll provide the information for your footprint, or you can even get that off the project box that we use with this. There's drawings for the project box too. It's exactly the same as our drawings for the fixture. Another thing I wanted to go over too, this is not the best way to do it anymore. These Destaco clamps on the side for the R&D fixture. We have something better. Let me make some bench space right here. Move this out of the way. We have, these are production fixtures. We also have a lower cost R&D fixture that does the same thing almost as these production fixtures. It's right here, and it also has the adjustable press downs that slide up and down and move back and forth. It's a more lower cost version of this. A lot less rugged than this, but it's good for R&D, pre-production, and you can put this board in here too. This is a 10-inch one. We'd have to show you, you'd have to get the 14-inch, but you can put this one in here and do the same exact thing with this, and it saves you from having to put these Destaco clamps on here. And you'll find out that it's a little bit hard to design this, and it's a little bit hard to always make it work. Like here, we put some different connectors on there, so this one really doesn't work anymore, and these components got moved in the way of this. So, and once they're kind of set, you don't have much of an adjustment. So you might want to consider using one of these instead of putting the clamps on there like that. Okay, this concludes the video of how to make your bed of nails fixture kit yourself, and hope it was informative. And if you want to see more videos like this, you can go to testelectronics.com.